Yes. Can you please confirm this by chat message? You can send in chat message. If you can hear me, you can just type yes. If the audio is clear, okay, yes. You're not supposed to annotate on the screen. Whoever is doing it, if you annotate on the screen, I'll have to put you out of the meeting room. So this is a level 2 class. So first we will discuss the level 2 MCQs of organic chemistry basic principles. Okay. Students, you know that in this particular chapter, we have four sections. Four sections. Okay. I'll tell you what those four sections are. I'll tell you what those four sections are. First section is the introduction part, introduction and basics, introduction part, introduction to organic chemistry, introduction to organic chemistry, where you study concepts like hybridization, hybridization, okay, then classification, functional groups, functional groups, okay, and concepts like homologous series, all this. Now, before I start, I should also make it clear to all students, please log in with your name. ನಿಮ್ಮ ಹೆಸರಲ್ಲಿ ಲಾಗಿನ್ ಆಗಬೇಕು. If you try to log in with the name of your cell phone or any other name, you will not be allowed into the meeting. Okay? Yes. And if you have to ask any question, you need to use the raise hand button. Okay? Use the raise hand button. Please log in with your name. Yes. So the first part includes this hybridization, classification, functional group, all that. Okay. And the next part includes, second part is nomenclature and isomerism. Naming of organic compounds, nomenclature and isomerism. That's the second part. The third part is one of the most important parts, which is organic reaction mechanism and electronic effects. Reaction mechanism, reaction mechanism, and electronic effects. Electronic effects. Yes, this is what we have discussed so far. And fourth part includes purification, purification, qualitative analysis, qualitative and quantitative analysis, quantitative analysis. Okay, these are the four parts in this chapter. ಈ four parts ಇರುತ್ತೆ ಆಯ್ತಾ. In today's class, we will discuss level 2 MCQs mainly from these three parts: introduction part, nomenclature isomerism part, reaction mechanism, and electronic effects. Okay. Now, the last part, purification, qualitative and quantitative analysis, we'll discuss it in another class. So today we'll focus on the first three parts. Okay. Now, apart from the level 2 MCQs, I will also be helping you out with the assignment MCQs. I'm sure, or I hope at least, that you're solving the MCQs from the assignment material we have provided. It has a lot of questions. Tumba questions there. In fact, there are more than 100 questions in level 1. Topic wise warm up. Topic wise warm up section has more than 100 questions. So worksheet has almost around 50-60 questions. With 100 questions in assignment, it will be almost 160 MCQs. If you solve those 160 MCQs, you would have covered all concepts. Okay. So what I'll do now is, after discussing level 2 MCQs, I will also select some questions from your topic wise warm up in your assignment booklets and also solve it. Aita? And in your assignment booklet, there are some questions on stereoisomerism. Stereoisomerism, each chapter lilla. Stereoisomerism comes in the next chapter and it also comes in second year PUC. So I will mark those questions. You can avoid solving those questions. Our questions ಈಗ solve ಮಾಡಬೇಡಿ. You don't have to worry about it. Okay. So questions related to stereochemistry or stereoisomerism, I will mark it. ಅದನ್ನ ನೀವು ಈಗ solve ಮಾಡೋದು ಬೇಡ. Right? Okay. So let me now um, show the questions here on the screen. I'll just post the questions. I want all of you to be ready with your level 2 MCQs worksheet, organic chemistry basic principles, level 2 worksheet. Okay. I'll just post the questions. Give me a minute. I'm sorry. I just lost connectivity. Let me share the screen. 1 second. Yes, I'm sharing the screen here. Yes, let me allow some of the students who are waiting in the waiting room. Again, I'm repeatedly telling you, please do not log in with the names of the cell phones. Okay, will not be able to allow you. You should come with your name. Yes. Okay. Anybody with answers? I'm waiting for the answers. Let me see who has given the answers for the first question. Yes. Kashif says A, option A for first question. Yes. Shashank also says option A. Good. Hemant also says option A. Good. Let's verify. Verify Marnaiga. Give me a minute. I'll just scroll down. Yes. See, in the class, I told you one simple idea to find out the hybridized state. If a carbon atom is involved in only one pi bond, it is sp2. If a carbon atom is involved in two pi bonds, it is sp. If a carbon atom has not formed any pi bond, it's sp3. This is a simple question. So here carbon 2 is sp. Carbon 3 has no pi bond. See, it's sp3. Carbon 5 has one pi bond, so sp2. Carbon 6 has no pi bond, again sp3. So the correct sequence is 2 is sp, 3 is sp3, then sp2, then again sp3. So all the students who said option A are correct. Yes. Okay. Next. Question number 2. Let me post question number 2. Just give me a minute. I just post question number 2 here. 1 second. Yes. So all of you be ready with the answers. Question number 2 is related to finding out the correct functional group. Okay. Good. I'm getting quick responses. Very good. Let me post the questions now. Yeah. I posted question number 2 and question number 3 together. ಒಟ್ಟಿಗೆ post ಮಾಡಿದ್ದೀನಿ ನೋಡಿ. Yes, for question number 2, I am getting the answers as I'm telling again, please mention the question number before you give the option. 2 ಅಂತ ಹೇಳ್ಬಿಟ್ಟು option mark ಮಾಡಿ. Okay. So most of you are suggesting option C. Good. It's anhydride. Very good. See, anhydride functional group is RCOOCOR. Clue here is if you come across 3 oxygen atoms like this, that's an anhydride. There is no other functional group with 3 oxygen atoms like this. So it's an easy clue. Okay. Very good. It's anhydride. In fact, it is actually a cyclic anhydride. ಇದನ್ನ cyclic anhydride ಅಂತ ಹೇಳ್ತೀವಿ. This is cyclic anhydride. Okay. Good. Right. Next question. Question number 3. Okay. Come on, send the answers. For question number 3, third one. Okay. Most of you are telling A, Sarika, Kashif, Kishan, Supash, Aditya. Very good. Jagan, option A. It's easy. You just have to match the structures with the bond line notation. So as you can see, cyanide groups here, the only option which has cyanide group is 3. So A must be 3. A must be 3. And in the exam, what you should do is, the only option with A as 3 is option A. So if that matches, see here, no other option has A as 3. The only option with 3 for A is option A. So that's how we can easily mark this. But for learning sake, let's verify. So A is for 3. Then B is, see, look at the branching. B will be 4 like this. C will be 1. And since it has OH group here, D will be 2. Easy. Good. Okay, let me get the next set of questions. Question number 4. Question number 4 in the Norna. 4 and 5. Okay. 4 and 5. Yes. Okay. The faster we complete this, the more questions from our assignment booklet we can solve. Nodi. The name of the compound under IUPAC system. Okay. Let me allow a few students who are waiting here. Okay. Yeah. Fourth question. How many of you given the answer? Let me see. Fourth question. Yes. Many of you suggested A again. Abhay, Shashank, Jashnath. Yes, yes. Nisha. Good. Nisha has suggested C. Most of you suggested A. Okay. Verify, Marna. Fourth one. Name of the compound under IUPAC system is. See, while discussing the rules, I told you that numbering of the carbon chain must be done from the end closer to double bond. Double bond should get the lowest number. So if you start numbering from left side, 1, 2, 3. So double bond gets position 3. But if you start numbering from the right side, 1, 2, double bond gets position 2. So this is correct. This is wrong. So 1, 2, 3, 4, and 5. So it is a pentwene. ಪೆಂಟುಯಿನ್. ನೋಡಿ ಎಷ್ಟು ಆಪ್ಷನ್ಸ್ ಇದೆ ಪೆಂಟುಯಿನ್ ಅಂತ. ಆಪ್ಷನ್ ಎ is pentuin and option D is pentuin, which means B and C are ruled out. You don't have to worry about it. And then look at the substituents. There is methyl group. 3 methyl groups are there at positions 2, 4 and 4. So it must be 2, 4, 4 trimethyl pentuin. That's good. Most of you said option A. Very good. Okay. Let me now check out the next answer here. Again, some of you are still logging in with the phone model. Please don't do that. I may have to remove you. Yes. Okay. Question number 5. How many of you give the correct answer? Question number 5. Okay. Pavana, Shobha, yes. Supash says C. Some of you are suggesting D. So there is a mixed response. Some of you are suggesting D, some of you are suggesting C. Okay, then we'll have to solve it. Okay. Yes. Again, same concept. Double bond should get the lowest number. Double bond lowest number kodbeko. Meaning this will be 1, this will be 2, this will be 3. Now the question is, should I go left side or should I go to the right side? If I go this side, say 4, 5 and 6, then I will end up with a complex substituent. Adakbardo. So I should go with this 4, 5 and 6. So this will be the longest chain, students. The main chain. This will be the main chain. Okay. Remember a rule we discussed? The chain with the maximum number of substituents. You can make a note in your books also. Chain with maximum number of substituents should be selected main chain. So in that case, this would be propyl group. Nodi, this is propyl group. And this is ethyl group. This is ethyl group. And E comes before P in alphabetical order. And therefore the correct naming is 4-ethyl. It is 4-ethyl 3-propyl hexanine. Option D would be correct. Option D would be correct here. Okay. 4-ethyl 3-propyl hexanine. So the only rule you have to be careful here is the rule that chain with maximum number of substituents is selected main chain. Carbon chain with more substituents will be selected main chain. Okay. Yes. That is the most important rule. Okay, good. Next. Let me bring in the next set of questions. Okay. Question number 6. Just give me a second. I'll just copy it. Question number 6 and 7. Let us pick it up together. Yes. Question number 6. You are given some structures and you have to find out which is the correct structure for the given name. Okay. I'm posting it. Notkoli. Which is the correct structure for the given name is what you have to find out. See. The correct structure of 2-ethyl, 3-methyl hexa, 1, 4 diene. Okay, let me look at the answers that you're giving. Please mention the question number. Yes, Jashanath says C. Samrut also says C. Kanishkar also says C. Good, good. Okay, okay. Elru almost C suggest madidara. Okay, good. So see here. Start from the root word. Root word in the start madi. Hexa. So it's 6 carbon atom, 6 carbon chain. 1,4 diene. See, in which case it is 1 and 4. Here it is 1, 2, 3, 4. So here also it's 1, 2, 3, 4. In all the cases 1 and 4. Then it says 2-ethyl, 3-methyl. Ethyl must be in the second position. So see this? Option B. Methyl is in second position, ruled out. Option D. Methyl is in second position, ruled out. Option A and C have ethyl in second position. So between A and C, you should check. Ethyl second position admele. Third position you have methyl. So which compound has third position methyl? Option A has methyl in the fourth position, so ruled out. That leaves us with one option, which is option C. And as you can see here, Now look at the numbering. 1, 2, 3, 4, 5, 6. So it is 2-ethyl, 3-methyl, hexa, 1, 4, diene. Perfect answer. Okay. Good. Next question. Let me try to bring in question 7 and 8 here together. Question 7, 8, and 9 together. I'll bring all the three questions. All the three questions are related to naming. Okay. I'm posting it now. Question number 7, 8, and 9. Okay. So 7, who can answer 7? Question number 7. Please mention the question number. Yes, Shobha says A. Harshita also says A. Dashanath, Kishan, Gaurav, Jagan, everybody says A. Okay. So A, ಎಲ್ಲರಿಗೂ ಗೊತ್ತಾಗಿದೆ ಹಾಗಾದ್ರೆ. Good. The compound which contains primary, secondary, tertiary, and quaternary carbon atoms is. Yes. We had discussed this in the class. Primary carbon and secondary, we had discussed this, right? So primary carbon is a carbon which is attached to only one other carbon. Secondary carbon is attached to two other carbons. Tertiary carbon, three other carbons, like that, okay? So which compound will have all the four types? As you can see here, 2, 2, 3. Since the numbers are repeating there, numbers repeat ಆಗ್ತಿರೋದ್ರಿಂದ, it indicates that more substituents are present on the same carbon, because of which you can have a tertiary quaternary possibility there. Let's write the structure and verify. Let's verify ಮಾಡೋಣ ಆಯ್ತಾ? See here. How do you write the structure from the name? Start from the root word, pentane. 1, 2, 3, 4, 5. Pentane. Okay. Then 2, 2, 3. At second position, there is methyl group. One more methyl group also at second position. Then one at third position. This is a structure. This is a structure given. Okay. This is a structure given. Now, how do I identify the primary ones? Let me show that in a different color. This is primary. This also is primary carbon. So is this. So, nodi, 5 primary carbons in there. Almost, yes. 5 primary carbons. This is secondary carbon because it's attached to two other carbons. This is tertiary carbon and this is quaternary carbon. Yes. So option A is right. Option is actually right. Yes. Let me mark it here. Good. Question number 8. Okay. I want one of you to tell me which functional group is this. Many of you have given the answer for this. Sri Lakshmi says 8. Rumana says B. Aditya says D for question number 8. So I'm getting a mixed response. Very response ಬರ್ತಾ ಇದೆ. Okay. First of all, who will tell me the functional group here? Let me see. ಯಾರು ಕರೆಕ್ಟ್ functional group ಹೇಳ್ತೀರಾ? I'm waiting. Anybody? Question number 8. Yes, Aditya, Yashat. Very good. They say Esther. Very good. Aditya and Yashat. Yashat, Esther. Yes, this is Esther. And how are Esters named? How are Esters named? Esters are named as alkyl alkanoid. Nodi? RCOOR is ester, right? So this part is called alkyl part. The part directly attached to oxygen. The carbon chain directly attached to oxygen is the alkyl part. And the carbon chain with the functional group is the alkanoid part. Alkanoid part. Now see this. Look at the structure. This C2H5 is directly attached to oxygen. So that becomes the ethyl part. So write ethyl. That becomes the ethyl part. And then see this. This entire part is the alkanoid part. And how do you name it? Number 8. Number Madi. 1, 2, 3, 4. So it's but, root word is but. And at the third position, there is double bond. Noti? Third position, there is double bond. So it is butene. And at the second position, and at the third position, there is methyl group. There is methyl group. So it is 3-methyl. Have a look at this. 3-methyl. 3-methyl. Root word is but. And third position is ene. 3-ene. And then since it's ester, the suffix is OH. Ready? Ethyl 3-methyl but 3-enoate. It is option B. Ethyl 3-methyl but 3-enoate. So ಈ ಕಾಂಪೌಂಡ್ ನೀವು ನೇಮ್ ಮಾಡೋದು ಕಲ್ತ್ಕೊಂಡ್ರೆ ಯು ಕ್ಯಾನ್ ನೇಮ್ ಎನಿ ಎಸ್ಟರ್, ಯಾವ ಎಸ್ಟರ್ ಬೇಕಾದ್ರೂ ನೇಮ್ ಮಾಡ್ಬೋದು. So that's why I've given this. Okay. Yes. Good. That was question number 8. Now waiting for your answers for question number 9. Okay. There is a request. One of you asked me to repeat question number 8. Who is that? Aditya has asked me to repeat question 8. Okay. So question 8 is, see, it's for the benefit of everybody. I'm repeating it. Any ester is to be named as alkyl alkanoate. The carbon chain attached to oxygen is the alkyl part. So I'll rewrite the structure. See this? Let me make it a bit bigger. CO O C2H5. That's how it's written here. Okay. Now, as you can see, this part is directly attached to oxygen, so it is ethyl part, ethyl. And then name it as a normal compound. One, this is a functional group carbon. Carbon atom of the functional group should always be numbered 1. You remember that, right? So this becomes 1, this is 2, this is 3, and here there's a double bond. Double bond there. Okay, that's why it is. Third position, methyl, 3-methyl. But, 1, 2, 3, 4, so but. Third position, there's double bond. And then OH, because it's an ester. That's how you give the name. Easy. Aita? Good. Okay, let me now go to the next question. Question number 9. Okay, let me see the answers for question number 9. A. Harshita says A. Preetham, Kishan, Chinmaya, all of you are saying A. Okay, let's verify. Akansha also says A. Okay, let's verify this. We scroll down. Just give me a minute. Let's scroll down. Yes, it's a cyclic compound, and we have discussed the rules of cyclic compounds. Okay. See, carbon atom attached to functional group OH must be numbered 1 always. And the next preference in numbering goes to double bond. So you should go anti-clockwise or counter-clockwise. This becomes 2, 3, and 4. Now check this. You have ethyl substituted at the 4th position. So it becomes 4-ethyl, 4-ethyl, cyclo, but 2, second position in. Okay. So 4-ethyl, cyclo, but 2-enol. Yes. Most of you are right. Said option A. This is correct. Ita? Very good. We have almost discussed 9 questions within 30 minutes. Good. Let's keep up this pace. Next question, Norna. Okay, question number 10. I think I remember solving the same example in the classroom also. Let's see. Same example in the classroom as well. Let's see who can pick it up. Question 10 and 11. I'll post it directly. 10, 11. Okay, question number 10 and 11. Be ready with the answers. 10 and 11. Yes. Yeah, who can give me the answer for question number 10? Let me see the chat section again here for question number 10. Jashanath says C, is it? Yeah. Okay. Sri Lakshmi also says C. Harshita says C. Okay. Most of you are going with C. Let me see. Yeah. This is a compound. See, benzene ring. Benzene ring with aldehyde group, CHO, is called benzaldehyde. It's the common name which is adopted IUPAC name. We have discussed this in the class. Benzaldehyde. Common name, which is also adopted IUPAC name. So this compound is to be named as derivative of benzaldehyde. Okay. So carbon with aldehyde is numbered 1. Numbered 1. Then the dilemma is, ಇಲ್ಲಿ ಏನ್ ನೀವು ತಿಳ್ಕೋಬೇಕು ಅಂದ್ರೆ, should we go clockwise or anti-clockwise? And see, if you go clockwise also, the position is 3. If you go counterclockwise also, position is 3. When numbering is same from both sides, what is the rule we should use? The substituent which comes first in alphabetical order should get lower number. This is bromo. This is hydroxy. Please note, OH is not to be treated as all. It is not the main functional group now. The main functional group is aldehyde. Nodi? Aldehyde is the main functional group. OH becomes a secondary functional group, which means that's a substituent now. Okay? So it will be called hydroxy. Now between bromo and hydroxy, which comes first in alphabetical order? Bromo. So this will be 1, 2, 3, 4, 5. So it is 3 bromo, 5 hydroxy, benzene carbaldehyde. So benzaldehyde, or it can also be called benzene carbaldehyde. Benzene carbaldehyde. Okay? Yes. That's right. Okay, then next. We shall go to the next question, question number 11. So question number 12, 10, answer is option C. Now coming to question number 11. The IUPAC name of the following compound. Yes, most of you are giving the correct answers. Very good. So 11th question, Gaurav says A. Kashif says A. Good. Rehan Sharif also says A. Chinmaya, Anishka, yes, yes. Aditya, all of you saying A. Good. So here, the main functional group you all know is cyanide, nitrile. So that carbon should be numbered 1. And this becomes 2, 3, and 4. And keto group as a substituent will be called oxo. Oxo. Okay. Yes. Now the name. So since this is the main chain, you have methyl substituents, methyl group substituent. So it's 2, 2, 2, 2 dimethyl, 2, 2 dimethyl, 4 oxo, pentane nitrile is correct. 2, 2 dimethyl, 4 oxo, pentane nitrile is correct. Good. Next question. Let me bring in question number 12. One second, I'll post it. Okay, 2 options are capturing in one frame. Let me post it twice. Let me post 2 more options. Just give me a minute. Yeah, ready. Question number 12. How many ready? 12. Option C. Prajit says option C. Abhay Surya says option C. Good, good. Okay. Rehan Sharif also says option C. Yes. Most of you are going with option C, which means this must be relatively easy. So functional group is carboxylic acid. See this? COOH, carboxylic acid. And now you have to number the chain. Always start from the main functional group. That is 1. One second. Yeah. Main functional group 1. Then 2, 3, 4, 5, 6, and 7. So what are the substituents then? There is methyl here on the 6th position. There is methyl on the 2nd position. So it must be 2, 6 dimethyl. 2, 6 dimethyl. See which option has 2, 6 dimethyl? Option C, straight away. Verify ಮಾಡೋದು ಬೇಡ ನೋಡಿ. Just if you know that it's 2, 6 dimethyl, that's the only option with 2, 6 dimethyl. Hence, that's the correct answer. So it's 2, 6 dimethyl hepta. Look at the positions of double bonds. 2 and 5. So 2, 6 dimethyl hepta 2, 5 dienoic acid. Dienoic acid. Yes. This is the correct answer. Okay, next. I think these are the questions on on nomenclature. Next, we have questions on isomerism. Isomerism Norna. Cyclobutane and butene represent cyclobutane and butene, all of you know, they are ring chain isomers because one is a ring, the other one is a chain. So it's ring chain isomerism. Ring chain isomerism. Yes, most of you given the correct answer. I think all of you given the correct answer. B. Good. Good. Okay. Dheeraj also says B. Yes. Babita says B. Good. Good. Easy. Next. Next question is on tautomerism. Tautomerism is something we discussed in the class. You remember? ನಾ ಹೇಳಿದೆ ನಿಮಗೆ ಎನ್ ಸಿ ಆರ್ ಟಿ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಟಾಟಮಿಸಮ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿಲ್ಲ ಬಟ್ ಇಟ್ಸ್ ಎಕ್ಸ್ಟ್ರೀಮ್ಲಿ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ ಯು ಟು understand some organic reactions. Okay, that's the reason why I told you about this in the class as well. Okay, who has answered it? Jagan says option B. Who else has answered for 14? Supash also says B. Okay, good. Let's see. Let's see. Abhay also says B. Good. Let's verify now. See, at this moment, I would like you to recollect two conditions for tautomerism. ಏನದು conditions tautomerismಗೆ ನೋಡಿ ಇಲ್ಲಿ see conditions for tautomerism. The conditions are here. First condition, um, presence of one or more alpha hydrogens. Presence of at least one alpha hydrogen atom. Presence of at least one alpha hydrogen atom. Okay. Second condition is presence of an atom. Presence of an atom attached to more electronegative atom. More electronegative atom through multiple bond. More electronegative atom through multiple bond. Yes. Okay. Yeah. So this are the two conditions. So which compound satisfies these two conditions? Check mark. Option A. There is benzene ring here. See, ಇದನ್ನ expand ಮಾಡಿದ್ರೆ I get the structure like this. See, benzene ring attached to C double bond OH. This carbon which I'm highlighting in red is alpha carbon, but there's no alpha hydrogen attached. So first condition itself is not satisfied. So this does not show tautomerism. Now come to option B. Again, benzene ring here. So there's no alpha carbon, but this side there is alpha carbon and alpha hydrogens. So first condition satisfied. What about second condition? Presence of an atom attached to more electronegative atom through multiple bond. Yes, you have that very much here. See, carbon atom attached to more electronegative oxygen through multiple bond. So yes, option B is the perfect example for tautomerism. In fact, you can also practice writing the tautomer structure. Practice ಮಾಡಿ. Try ಮಾಡಿ tautomer structure ಬರೆಯೋಕೆ. At told this in the class. How to do it? How to write the tautomer structure? C6H5 benzene ring. Also, students, please note, whenever you come across C6H5, that's called phenyl. Phenyl. And it stands for benzene ring as a substituent. This is phenyl. ಆಯ್ತಾ? So benzene ring, CO and CH3. Now, how do we write the tautomer form? Here I should make changes. See, let me remove the alpha hydrogen here. So that makes it 2. Therefore, you get double bond here. And since carbon can't form 4 or 5 bonds, this bond is gone. And this becomes OH. That's the enol form. Enol. This is keto. Very good. That is how you should recognize tautomerism. Okay. Right. Let me bring in the next question now. Question number 15. Yes. Now we have questions on electronic effects. Electronic effects and reaction mechanism. Is related questions. Okay. Let me bring in question number 15 and 16 together. And for example, even 17. Okay. I can bring in 17 as well. 15, 16, 17. At once we can discuss. Students, from this week onwards, your level 2 classrooms will increase. Level 2 class sessions will be more. Okay. Sometimes in the weekday also we'll conduct the level 2 class. So you have to cooperate. Maybe one class on weekday, one class on weekends. Okay. You have to cooperate. So now that you are, exposed to solving MCQs. Midterm exam is over. Little bit of pressure is eased out. Eager level 2 classes ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಮಾಡೋಣ ಆಯ್ತಾ. So this week you'll also have some classes from maths, and next weekend you'll also have classes from physics as well. Okay. Yes. Yes. The correct order of minus I effect of the following substituents is correct order of minus I effect. I'm highlighting it. Okay. See, one of the strongest electron withdrawing group by inductive is nitro. Nitro is the strongest. ಇದನ್ನ ಆರ್ಡರ್ ಬರೀತೀನಿ ನೋಡಿ. Order of electron withdrawing capacity. Order of electron withdrawing. I'm sorry. 1 second. Scroll down. Yeah. Order of electron withdrawing substituents is nitro greater than cyanide, then greater than chlorine. Aita? So nitro is stronger than cyanide, cyanide is stronger than chlorine. Now let's therefore verify this. See which option has nitro, third option has nitro. But nitro is on the second carbon from the group. Nodi. This connecting bond is the bond by which the group is attached to main chain. So NO2 is 2 carbon atoms away. Whereas, look at this example. 1 chlorine atom is right on the first carbon. Now, how does it matter? Why should that matter? That matters because you all know inductive effect is distance dependent. Very important point. Inductive effect. Distance dependent. Distance dependent. It decreases with increase in distance. With increase in distance. You need to understand this. It decreases with increase in distance. Okay. Yes. Next. So chlorine here is present on the first carbon itself. And think about another example where the group is present on the first carbon. Look at fourth one. Cyanide, strongly withdrawing group, is present on the first carbon. So 4 and 1 must be top because the withdrawing groups are present right on the first carbon. So they'll have the strongest inductive effect. And between cyanide and chlorine, which is stronger? Cyanide is stronger. Therefore, 4 is greater than 1. 4 is greater than 1. ಇದು ಗೊತ್ತಾಯ್ತು. ಈಗ 2 ಮತ್ತೆ 3 ಮಧ್ಯೆ ಡಿಸೈಡ್ ಮಾಡ್ಬೇಕು ನಿಮಗೆ. That's easy. 3 has nitro group, 2 has chlorine. Nitro is stronger than chlorine. So 3 must be greater than 2. 3 must be greater than 2. And here 1 is greater than 3. So what the correct order then? Increasing order. 2 less than 3 less than 1 less than 4. I think it's option B. 2 less than 3 less than 1 less than 4. Let me see who all have given the correct answer for this question. Question number 15. 15. ತುಂಬಾ ಜನ C ಹೇಳಿದಿರಾ. Abhay has said B. Okay. Lot of you have said C. So small confusion there. ನೋಡ ನಾನು ಏನಾದ್ರು ಮಿಸ್ಟೇಕ್ ಮಾಡಿದನ ಚೆಕ್ ಮಾಡ್ತೀನಿ. Chlorine comes least. 2 is least. Yeah. Then comes 3. Then comes 1. And then 4. Yes. B is the answer. B is the answer. Okay. Be careful. Cyano is stronger than chlorine in withdrawing effect. Okay. So some of you may be thinking, sir, ಇದೆಲ್ಲ ಹೆಂಗ್ ಗೊತ್ತಾಗುತ್ತೆ? Nitro stronger, cyanide stronger, ಹೆಂಗ್ ಗೊತ್ತಾಗುತ್ತೆ? See, by solving more and more MCQs, getting exposed to more and more examples, you'll collect this information. And that becomes your learning. ಈಗ ಈ example ಗೊತ್ತಾಯ್ತು. Nitro is stronger than cyanide, stronger than Cl. So more such examples you solve, you'll get more such information, data. Okay. And that should go into your synopsis. I hope you all remember. I'd asked you to prepare chapter synopsis. I don't know how many of you are taking it seriously, but some of you are really, doing it and showing it to me. I've seen some of you writing really good synopsis. But ಎಲ್ಲರೂ serious ಆಗಿ ತಗೋತಾ ಇಲ್ಲ ಅದನ್ನ. Let me tell you, for your entrance exam preparation, success in entrance exam depends on how well you have retained the concepts. So they can think fast. ಆ ಫಾಸ್ಟ್ ಥಿಂಕಿಂಗ್ ಬೇಕು ಅಂದ್ರೆ ನಿಮ್ಗೆ ಸಿನಾಪ್ಸಿಸ್ ಇರಬೇಕು, ಚಾಪ್ಟರ್ ಸಿನಾಪ್ಸಿಸ್, ಸೊ ದಟ್ ಯು ಕ್ಯಾನ್ ರಿವೈಸ್ ಇಟ್ ಅಗೇನ್ ಅಂಡ್ ಅಗೇನ್ ಅಂಡ್ ಅಗೇನ್. ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಥವಾ ನೋಟ್ಸ್ ಇಟ್ಕೊಂಡು ರಿವೈಸ್ ಮಾಡಕ್ಕಾಗಲ್ಲ. ಯು ಕೆನಾಟ್ ಡೂ ಫಾಸ್ಟ್ ರಿವಿಷನ್ ವಿತ್ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಆರ್ ನೋಟ್ಸ್. ಯು ಹ್ಯಾವ್ ಟು ಪ್ರಿಪೇರ್ ಎ ಸಿನಾಪ್ಸಿಸ್. ಓಕೆ, ಸೊ ಸ್ಟಿಲ್ ಇಫ್ ಯು ಹ್ಯಾವ್ ನಾಟ್ ಡನ್ ಇಟ್, ಟೇಕ್ ಇಟ್ ಆನ್ ಅ ಪ್ರಯಾರಿಟಿ ಬೇಸಿಸ್. ಮಿಡ್ ಟರ್ಮ್ ಎಕ್ಸಾಮ್ಸ್ ಆಗಿದೆ, ಟೇಕ್ ಇಟ್ ಆನ್ ಅ ಪ್ರಯಾರಿಟಿ ಬೇಸಿಸ್ ಅಂಡ್ ಸ್ಟಾರ್ಟ್ ಪ್ರಿಪೇರಿಂಗ್ ಸಿನಾಪ್ಸಿಸ್. ಓಕೆ, ಅಂಡ್ ಆಲ್ ದ ಲರ್ನಿಂಗ್ ಯು ಗೆಟ್ ಥ್ರೂ ಕ್ವಶನ್ಸ್. ಈಗ ಇದು ಕ್ವಶನ್ ನಂಬರ್ 15 ಸಾಲ್ವ್ ಮಾಡಿದ್ರಿ. The learning here was you got to know that nitro is stronger than cyanide, cyanide is stronger than chlorine. This information should go into the synopsis. So next time when you're studying synopsis, you revise that. You don't have to come and solve this question again. Okay, that is the intention with which we, I'm asking you to write synopsis, not just for chemistry. Ella subjects ku ಮಾಡಬೇಕು, synopsis ಬರಿಬೇಕು. Okay, maybe for biology that's not possible because every line you can get a question. So there, use a highlighter and highlight every line and study. For PCM, you should make chapter synopsis. Okay, question number 16. Now, I'm scrolling down. Carbon-carbon single bond. Let me highlight it. Carbon-carbon single bond and carbon-carbon double bond lengths are equal in. First of all, tell me, under what situation carbon-carbon single bond and carbon-carbon double bond both can be equal? Due to which phenomena? Good, good. Resonance. Who said that? Chinmaya. Very good. Resonance. Preetham also says the same. Yes. Resonance. Shweta. Yes, yes. Correct. Resonance is the reason. So all that you have to do is find out which compound shows resonance. Ashte. Buta 1,3-diene. First of all, buta 1,3-diene. Does it show resonance? Let's check. 1, 2, 3, 4. 1 and 3. Yes, it shows resonance. So that's the answer. This must be the answer. Easy. Now check out cyclopentene. Cyclopentene. No conjugation, no resonance. So bond lengths equal agalla. Cyclohexa 1,3-diene. Let's check. Cyclohexa 1,3-diene. Students, this is an interesting example. Interesting example. There is conjugation. Conjugation is there, but only for half the molecule, not the whole molecule. That's why this is not the correct answer. But buta 1,3-diene, conjugation throughout the molecule. Therefore, that's the correct answer. This is the correct answer. Okay. Fine. Now coming to question number 17. Question number 17. In which of the following molecules I effect and R effect are reinforced? Reinforce andreno? Both must be in the same direction. If it is plus I, resonance also must be plus R. Plus I plus R will reinforce. Minus I minus R will reinforce. Okay. So let's verify now. In which of the following molecules inductive and resonance both are in the same direction? Okay. Here chlorine pulls it this way. Bromine pulls it this way. Not in the same direction. Option B. Nitro is withdrawing minus R. Minus R. Okay. This is also withdrawing from this side. Minus I. Again, so inductive and resonance. Okay, let us verify here. Resonance with inductive compare ಮಾಡ್ಬೇಕಲ್ವಾ ನೋಡೋಣ. Resonance structure ಬರ್ದು ತೋರಿಸ್ತೀನಿ ನಿಮಗೆ ಆಯ್ತಾ. So chlorine and bromine. Here bromine shows resonance. E direction move ಆಗುತ್ತೆ. Okay. It's plus R. But chlorine bromine show both minus I. So one is plus R, one is minus I. Doesn't reinforce. Reinforce agalla. Now come to option B. In option B, nitro group. Look at nitro group. NO2, double bond O and O. It shows minus R. At the same time, it shows minus I also. See? Nitro group is a group which shows negative resonance, negative inductive. So that will reinforce. So this must be the answer. This must be the answer because it reinforces. Now, let me bring in this alkoxy group. Alkoxy group, OR. It has lone pair. So shows plus R. Alkoxy group, any atom with lone pair attached to conjugate system shows plus R. But this group also shows minus I. So doesn't reinforce. Again, same thing here. Plus R. But minus I doesn't reinforce. So answer is option B. Athaitala, all of you understood this? Let me see who has given the correct answer for this. Question number 17, Jashanath says B. Good, good. Inyara Helidira. Yes. Supash also said B. Gaurav, Shweta, Chetan, Babita. Yes, yes. Option B. Good, good. Next question, Norna. Students, hope I'm not going fast. But these are level 2 questions. We have to discuss it at this pace. Okay, because you have already learned the concept, studied it, level 1 solve agide. So level 2, you have to be fast. Now I'm bringing question number 18 and question number 19 together. Question number 18, question number 19. And please do write down the explanation. Sumne option tick marta kutkobaardu ನೀವು class ಅಲ್ಲಿ. Okay? MCQ's discussion means all the inputs I'm giving you, you should note it down. Either in your worksheet booklet or in a separate page. All the inputs you should write. Because in my explanation, I will not just focus on the correct answer. I will also tell you why the other were wrong. Why the other options were wrong. That is also different learning for you. Additional learning for you. Okay? So it's not just about focusing on the right answers. It's also knowing why the other options were wrong. Right? So all those things you should write down. ಸುಮ್ನೆ ಕುತ್ಕೊಂಡು ಆಪ್ಷನ್ ಸ್ಟಿಕ್ ಮಾಡ್ತಾ ಇರೋದಲ್ಲ. ಇದೆಲ್ಲ ಬರ್ಕೋಬೇಕು ನೀವು. Okay. Good. Let's take up the next questions. Question number 18 and 19. Yes. Question number 18 and 19. The molecule which exerts inductive, mesomeric, and hyperconjugation effect, all the three. Let's look at the chat section. All the three. Okay. Most of you are suggesting A. ಎಲ್ರು A ಹೇಳ್ತಾ ಇದ್ರ. Very good. Very good. Let's check. All of you are suggesting A. Okay. Let's check. So first, let's see whether inductive effect is there. Remember, inductive effect is something which is universal. ಎಲ್ಲ molecule ಇದ್ದೇ ಇರುತ್ತೆ. As long as there is electronegativity difference. The only requirement for inductive effect is there must be difference in electronegativity. If I write chlorine molecule, Cl2, there is no inductive effect here. Okay? So inductive effect requires electronegativity difference. As long as the difference is there, inductive effect is there. So almost all molecules will have inductive effect. Okay? Mesomeric effect, which is resonance, requires conjugation. Let's see whether option A has conjugation. Yes. Double bond here and double bond here. Conjugated. Double bond conjugation. So inductive, yes. Let me write it here. I effect is there. R effect is also there. Hyperconjugation. What's the requirement for hyperconjugation? Remember the definition for hyperconjugation? Delocalization of sigma electrons of the carbon hydrogen bond of the alkyl group attached to unsaturated part or attached to unsaturated system. So see this group perfectly fits the definition. See, it perfectly fits the definition. CH3 is the alkyl group which has carbon hydrogen sigma electrons, which will be involved in delocalization with the unsaturated system. So hyperconjugation also exists. H. So you all are right. It is option A. Okay. Students, tell me which are the effects in option B? ನೋಡೋಣ ಹೇಳಿ ನೋಡೋಣ ಆಪ್ಷನ್ ಬಿ ನಲ್ಲಿ ಯಾವ್ಯಾವ ಎಫೆಕ್ಟ್ಸ್ ಇದೆ enter R, I or H. Preetham says inductive. Good, good. Supash says inductive. Jasnath, yes, yes, very good. Only inductive effect. No resonance, no hyperconjugation in option B. Come to option C. In option C, tell me which are the effects present? R, resonance, yes, yes. And inductive will always be there. Inductive is there. Good, good. Everybody is suggesting resonance. Resonance and inductive. Inductive has to be there. No hyperconjugation. In option D, come on. H and I, very good. Yashat says hyperconjugation, inductive, both. Yes. Option D has inductive and hyperconjugation. Yes. Good. Okay. Okay. That was about question number 18. Now coming to question number 19. Question number 19 is of a slightly higher order. Actually, you'll understand this better when you come to second year. But let me still try to, help you out here. It's a slightly higher order. Let me scroll down. Yes. In which of the following alcohols CO bond breaks heterolytically? with greatest ease. Meaning, the question here is you have to find out in which of these given alcohols, A, B, C, D, in which case COH bond breaks easily. Now, please remember, if the bond has to be broken easily, then the corresponding intermediate form must be stable. So let me just show this to you, okay? I'm just showing this to you by taking some general example. ROH. ROH. You want to know how easily this bond is broken. To know that, if you consider heterolytic bond breakage, you should be getting R plus and OH out. In fact, it won't split like that actually. ಈ ತರ ಸ್ಪ್ಲಿಟ್ ಆಗಲ್ಲ. ಅದಕ್ಕೆ ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ಕಂಡೀಷನ್ಸ್ ಇದೆ. ಆಸಿಡ್ ಇರಬೇಕು. OH becomes water and then it leaves. These conditions are there. But let's try to keep it as simple as possible. So ROH gives R plus. And what is R plus? You all know. You all recognize this intermediate. Who can name this intermediate R plus? Come on, let me see. Who can name R plus? Which intermediate is that? Species. Yes. Carbocation. Correct. Supash says carbonyl cation. No, it's carbocation. Okay. Good. Carbocation. So the intermediate here is carbocation. Carbocation. Now the explanation is simple. Whichever alcohol here gives a more stable carbocation, then that alcohol will have the bond broken easily. I repeat, if the bond has to be broken easily, that means the intermediate form must be stable. Meaning, if the intermediate is stable, the bond is broken easily. So find out in which alcohol intermediate is formed is more stable. Let me write the intermediate in each case. Option A. What's the intermediate? CH3, CH2, CH2 plus. Okay, students, while discussing carbocations in the class, as additional information, I told you about 3 types of carbocations. You remember that? Primary carbocation, secondary carbocation, tertiary carbocation. What is this type? Option A. What type of carbocation is that? If you can give the answer. What type of carbocation is option A? Okay, I get an answer as secondary. No. Many of you are telling secondary. No, it's primary. It is primary. Yes. I'll tell you why some of you said secondary. I'll tell you. I'll remove this misconception. ಏನ್ ಮಾಡಿದ್ರೆ ನೀವು ಅಂದ್ರೆ those who said secondary, what you did was you counted 2 carbons here. Carbon 1, carbon 2, and then said secondary. That's not how it is. You should find out how many carbons are attached to this carbon with positive charge. Nodi. Primary, secondary, tertiary is decided based on how many carbons are directly attached to carbon with positive charge. Only one carbon is directly attached. The other carbon, this carbon, is not attached to carbon with positive charge. So don't consider it. Consider only those carbons which are directly attached. Okay? So only one carbon is attached. This becomes primary. This is primary. Good. Okay, let me bring in second option B here. Option B, what's the carbocation? CH3, CH plus, CH3. Come on, what's this then? What is this? Yes, now it's secondary. Yes, secondary. This is secondary. Yes, secondary carbocation. And option C, I'll remove this OH. Get the carbocation you get CH3, C, CH3, CH3 plus. What type is it? It is tertiary. And option D again, check it. CH3, C, CH3, CH2, CH3 plus. What type is it? Again primary, because this carbon with positive charge is attached only to one carbon. It is attached only to one other carbon. Okay, so primary. Now, students, tell me, what was the order of stability I gave you for carbocations? Just type in your chat box. 1 greater than 2 greater than 3, or 3 greater than 2 greater than 1. 3 to 1. Yes, yes. Most of it is in 3 to 1. Very good. Mohammad Kashif says 3-1. Kishan says 3-1. Good, good, good. Babita says 3-1. Good. That's how it is. Tertiary greater than. See, order of stability. Tertiary carbocation greater than secondary, greater than primary. Now let's come back to the question. Is to find out in which case the bond breaks with greatest ease. And for that, the intermediate must be most stable. Most stable intermediate. Most stable intermediate. And which is the most stable intermediate? Tertiary. That's why this alcohol will have the bond broken easily. Stay easy. Simple. Please make a note of all this. Make a note of this, all of you. Not ಮಾಡ್ಕೊಳ್ಳಿ ಇದನ್ನ. In the meantime, I'll get the next set of questions. Yes. So last two questions on electronic effects. And after this, we'll take up some sample questions in our assignment. Okay. Yes. Question number 20. So these are all carbon ions. Carbon ions. We have to analyze the stability. So like carbocations, even carbon ions can be classified as primary, secondary, tertiary. But here, the stability order is completely reverse. In case of carbocation, it was tertiary greater than secondary greater than primary. Now it is primary greater than secondary greater than tertiary. Important. Okay. So we have to find an order of stability. Let's identify each one of it. Option one is primary. It must be more stable. Option two is also primary. Primary. On top of it, it is stabilized by resonance also. See this? Double bond negative charge resonance. One of the 5 cases we discussed in the class. Double bond conjugation. Double bond lone pair conjugation, double bond positive charge conjugation, double bond negative charge conjugation, double bond free radical conjugation. Wow, right? So this is resonance stabilized. So something which is resonance stabilized is much more stable. So 2 must be the top now. 3 secondary. And 4 must be the least stable because see here, all of you, negative charge is right on the double bond. Too much of electrons. Too much of electron density results in repulsion. So stability comes down. So 4 must be the least. 4 least Iveco. 4 is least. Followed by secondary, which is 3. Then between 2 and 1, 2 is more stable because it's resonance stabilized. So it's 2 greater than 1, greater than 3, greater than 4. Which option matches this? 2 greater than 1, greater than 3, greater than 4 is option D. Good. Option D. Very good. Okay. Right. Then let's go to question number 21 now. Again, same order of stability of free radicals. Free and the stability order is Student, I'm so sorry, I by mistake muted it. Okay, I'm so sorry. So chat section ಯಾರಾದ್ರೂ ಹೇಳಿದ್ರಾ ನೋಡೋಣ. Okay, so I didn't see the chat section also. I'm so sorry. I'm so sorry. Yeah. Which part of the which question did we miss? Is it 20 was done or 21 you missed? 20 or 21? 21. Okay. Okay. I'll explain 21 again. I'm so sorry. ಹೆಂಗ್ ಮ್ಯೂಟ್ ಹೋಯ್ತದು ಗೊತ್ತಾಗ್ಲಿಲ್ಲ ನನಗೆ. Okay. I'm so sorry. I should have checked the chat section at least. Okay. 21, I was telling you, free radicals are also analyzed the same way as carbocation is analyzed. So the order of stability of free radical is same as that of carbocation. See, same as that of carbocation. And here, four is primary, least stable. But much worse is 2 because it has radical on the double bond. Then 1 and 3, both are resonance stabilized. This is called allyl radical. This is called allyl radical. Thank you, Vihan, for calling me and letting me know. Okay. Then this is called benzyl radical. Benzyl radical. Okay. Yes. Allyl radical, benzyl radical. And both are stable. Benzyl, in fact, is more stable than allyl because there are more resonance structures. Greater the number of resonance structures, greater stability. You should keep that in mind. So benzyl has more resonance structures because more double bond. See, that means more delocalization. So more stability. So order of stability is 3 greater than 1 greater than 4 greater than 2. So which option is correct? 3, 1, 4, 2. 3, 1, 4, 2. Option A. That's right. 3, 1, 4, 2. Option A. Yes. Okay. So that's all about your level 2 MCQs on these topics till reaction mechanism and electronic effect. The remaining questions are on qualitative quantitative analysis, which we'll take it up in the next meeting. Okay. And now let me help you out with some sample questions from your assignment. Last 15 minutes to go. I will just share some questions from your assignment. Okay. Just give me a minute. I'll import. Okay. I'm going to select a few questions. Some of the questions are very similar. You can easily handle it. Okay. Let me select. I'm posting it now. Yeah. Question number 4. I'm posting it. Please refer to your topic wise warm up. Okay. Topic wise warm up book. Scrolling down. Yes. Number of sp2 sp. I'll rewrite it because the image quality is not good. sp2 sp sigma bond. Okay. So how many formed between sp2 and sp? Please check. This is sp2. This is also sp2. But these two bonds. So how many sigma bonds are formed between sp and sp2? This is one sigma bond and sp2. So answer is 2. Remember, I discussed this kind of examples. ಈ ತರ ಕಾಂಪೌಂಡ್ಸ್ ನ ಅಲೀನ್ಸ್ ಅಂತ ಕರಿತೀವಿ ಅಲ್ವಾ. Okay, next. Let me see what's the next question that I can interesting where you're supposed to find the ratio of primary, secondary, and tertiary hydrogen atoms. Question number 8, I'm talking about. Question number 8. Topic wise warm up. Question number 8. Let me post it here. Yes. In the following structure given here, the ratio of primary, secondary, and tertiary hydrogen atoms is. See, be careful here. What they've asked is hydrogen atoms, not carbon atoms. We know what a primary carbon is. We know what a secondary carbon is. Okay. So, what are primary, secondary, and tertiary hydrogens? Easy. Hydrogen atoms attached to primary carbon are primary hydrogens. Hydrogens attached to secondary carbon are secondary hydrogens. Okay. And hydrogen attached to tertiary carbon is tertiary hydrogen. There cannot be any quaternary hydrogen because quaternary carbon will have no hydrogen attached to it at all. Okay, ignore. This is a quaternary carbon. Quaternary carbon has no hydrogen attached to it. So there's nothing like quaternary hydrogen. Okay. So now let's look at the ratio. So first let us mark all the primary ones here. This is primary. This is primary. So is this, as well as this. All these are primary carbons. And look how many hydrogens are attached to it. 3, 6, 9, 12, 15. So primary would be 15. Is to secondary now. Which are the secondary ones? This is secondary. This also is secondary. So is this. So how many now? 2 plus 2, 4. 4 plus 2, 6. 6 secondary is to tertiary hydrogens. I think I could spot only one tertiary carbon. So only one tertiary hydrogen. So 1. 15 is to 6 is to 1. Now bring it to the simplest ratio. So if you can see 5 here, that means it was divided by 3. 15 by 3 is 5. 6 also to be divided by 3, that becomes 2. 1 also to be divided by 3, that becomes 0.33. Which is the correct option? Option C. Easy. Good. I hope all of you have solved such questions. You have no issues with such questions, okay? Let me bring in a few more. I'm just selecting the questions, okay? 9th question is there. Then better. Bond line notation is there. 10th one, enolic form of acetone contains. I think once you know what the enolic form, then it's easy. Let me see if there is any question in nomenclature that, see, question number 12, nodi. An organic molecule necessarily shows optical activity. That's not there in the syllabus right now. It comes in second year, so ignore it. Question number 12, ignore. Question number 13 also, ignore now. Stereoisomers comes in second year again. So don't worry about it now. Okay. Question number 16. Let me tell you, select one question on isomerism. Keto enol tautomerism. 16. Tautomerism is there. You have to know about it. So I'm posting it now. Keto enol tautomerism question. Question number 16. Yes. Keto enol tautomerism is observed in. Just now we solved a similar question, right? C6H5. Sorry. Idalla. 1 second. I'll just erase it. Observe this, all of you. C6H5 OCH3 ante ನೋಡಿ. Here there is no double bond, multiple bond illa. So for tautomerism, one condition is there must be multiple bonds. So B is ruled out. C6H5CHO, I told you, benzene ring attached to aldehyde. There is multiple bond, but there's no alpha hydrogen. No alpha hydrogen. So A ruled out. Let's look at option C. Benzene ring. Then it has C double bond O. Then it has CH2. Then it has COH. Now let's verify whether the conditions are satisfied here. First condition, presence of alpha hydrogen. Yes, it is there. This is alpha carbon, has alpha hydrogen. So first condition satisfied. Second condition, atom attached to more electronegative atom through multiple bond. That condition is also satisfied. So yes, option C is the answer. Option C is the answer. Good. Okay. Next question. Let me select questions here. See question number 18. Ignore. Compounds 1 and 2 can be regarded as again isomerism, stereoisomerism, not part of first chapter. Question number 19 also ignore. ಈ ತರ questions ತುಂಬಾ ಬಂದ್ಬಿಟ್ಟಿದೆ ಇಲ್ಲಿ, ಅದನ್ನ ignore ಮಾಡಿ. Don't worry about it now, okay? Because stereo isomers we are going to study in second year and also some part of it in the next chapter of organic chemistry. I think IUPAC nomenclature questions were all easily manageable, right? Okay, let me take up another question on tautomerism. Question number 21. That looks interesting. 21. Tautomerism. Okay. Let me scroll down. Question number 21. Yes. Tautomerism is exhibited by which of the following compounds? Tautomerism is exhibited by which of the following compounds? Okay, let's go one by one. See, questions like this are quite common in NEET and JEE, where instead of just picking one option, they would be giving you multiple options, 1 and 3, 1 and 2, 1, 2 and 3. ಈ ತರ ಬಂದಾಗ ಟೈಮ್ ಜಾಸ್ತಿ ತಗೊಳುತ್ತೆ. So that's when you have to be very fast, because selecting one out of four is easy, but making multiple selections takes time. See this one, carbon oxygen double bond is there. There is alpha hydrogen also. You know, if nothing is written, it's hydrogen in bond line notation. So yes, this undergoes tautomerism, no doubt. Il ನೋಡೋಣ. There is carbon nitrogen double bond in OH, right? N and OH. See this part, C double bond N OH. Now students, please observe. Is it not like a enol? Since it's like enol, let's verify it. I can write the other tautomer form. See, CH, because this H now gets attached to carbon. Double bond becomes single bond, and N single bond O becomes N double bond O. Yes, this also shows. So 1 and 2 ಆಯ್ತು ನೋಡಿ. ಯಾವ ಆಪ್ಷನ್ 1 and 2 ಇದೆ, A ಇದೆ, C ಇದೆ, D ಇದೆ. So help ಆಗಲ್ಲ, ಇನ್ನು ಮತ್ತೆ ಎಕ್ಸ್ಪ್ಲೋರ್ ಮಾಡಬೇಕು. Look at 3. 3 also has alpha hydrogen. See, I can write the tautomer form of this. Look at how I can write the tautomer form of this. Double bond O, double bond O, double bond and OH. I can write this. Correct? Okay. So this also shows 1, 2 and 3 shows. 4 does not. Because I can't, there is alpha hydrogen, but I can't write one more double bond here. It'll already double bond ಇದೆ. When there's a double bond there, I can't write one more double bond. So 4 is ruled out. So correct answer is option A, 1, 2 and 3. Such questions are nowadays common, very common in NEET and JEE. CET ಈ ತರ questions ಬರೋದು ಕಡಿಮೆ. But in 2000, from 2025, NEET level has increased. So such questions are common. Okay. Yes, I think students will stop at this. You might have had a lengthy day today. Okay. So tomorrow, all of you know that you have special classes tomorrow. It's a working Sunday. So you have additional classes, right? And next Sunday is your CET test, test number 5. So syllabus is announced. Start preparing well for it. Okay. Thank you, all of you.